Okay, we're in the section on graphing trigonometric functions. Again, I want to repeat this to you. That's just going to be consistent week to week. We're going to be going through a lecture. It's important you pay attention to those lectures and try to make sense out of what's being presented to you. We try to organize things for you in these notes. So you should have these notes in your possession. After you're done with section 2 of the notes, you're going to certainly, it's a lot of work to get through it, but you'll get through it if you try. Then you're going to do the WebAssign. That's the Math 120 topic 2. Also try to enter something in the weekly discussion group that you think might help other students learn the material as well. All right, so we went through this. We went through graphing trigonometric functions. We gave some, pictures. We talked about the characteristic features in those pictures, mins, maxes, x and y intercepts, the periodic behavior of these things. They keep repeating themselves. These are parent functions. Little videos next to this that would go through the 5 characteristic points on that graph there. All right. Then we did cosine. These are really important curves. Again, there's a little video over there for the students that want to look at those videos. Then we did the tangent. What's different about the tangent now is it's got these asymptotic behavior in it, and we want to make special note of that. We still talked about 5 characteristics. All right. We had 3 points and 2 asymptotes for one cycle of it. All right. We talked about the characteristics of the cotangent. We talked about the characteristics of the secant and the cosecant. We talked about the use of a calculator, how to use a calculator, and why you'd want to use a calculator to do some of these problems over here. We also talked about the technique to learn the Math 119, which is basically a standard translation problem. Of course, a lot of students have trouble with that. So what I would recommend you do is what's called a point translation instead. And that's the techniques we were following in class. Certainly simple translations are easy to do. When you start making combinations of like A, B, C, and D, it gets a little bit difficult, all right? Bottom line, we did have some conventions we did mention. One was phase shift. Sometimes it's difficult to detect a phase shift, right? You're looking at a curve, you know, those are moved around because they're periodic, right? Amplitude, though, that's going to be something we're going to see in the sine and cosine. We're going to see the period of these functions over here. How long does it take to complete one cycle of it, all right? We went through examples. The examples that we did had points. We listed the points for you, and we gave you graphs of those things. Those graphs are accurate. I do want to point out sometimes the scale along the X and Y are different, though. So it may look a little bit different depending on what graphic systems you're using, including if you're doing this in paper and pencil. So the scale sometimes on Y and X is different. We kind of squish it up or sometimes or expand it out. So we did a bunch of examples, all right? Of course, the thing you should be doing along here is once you catch on, you say, I want to try. We want you to try. We really want you to try, right? Now, so the section of trying, let me get to that, is these supplemental activity things. This is something you do outside the classroom. It's expected you actually do this outside the classroom. In other words, you start reading textbooks, you start going to the internet, maybe watching YouTube videos, maybe talking to your friends, maybe just simply getting a study group at school, whatever works for you. But you need to supplement your education by study. All right. Then there's homework. This is paper and pencil homework. I'm going to go to that. And when I'm going to do that, I'm going to go to a whiteboard. And on the whiteboard, what I'm going to do is talk about what we want you to do, right, when you're doing the homework. Now, of course, you can watch me do this, but this is what we want you to do. So let me do that. I'm going to do another share. I'm going to share a whiteboard with you. And just give me 1 second. Okay, I realize I shouldn't say, oh, where'd the notes go? You have the notes. They've been given to you free of charge. You need these notes in front of you. So I just want to point out what we're doing over here. Let me just push this on the side for a second. We're in section 2 of the notes. These are the notes, and we're actually doing the homework. If you've followed along in lecture, this should just reinforce what we've done in lecture. That's all it's doing. So what they want me to do for number 1, this is in the homework, they want me to graph y equals 3 cosine 4x. All right, the way we've been doing this is we've been doing what's called a point translation. And certainly the parent cosine curve, we like to begin it at 0. So we're going to say 4x, this is the argument of the cosine function here, is equal to 0. This is what's known as the beginning, and we want to do the ending of it. And the ending of it is where 4x equals 2 pi. All right, this is for one cycle, by the way. So this means x is 0, and this means x equals, well, let's see, a half of a pi, right? All right, so I'm going to put my table up. And what's nice about a table here, it should be easy to generate it. And it's going to be x and y. It's going to be a very simple problem. We're starting at 0, and I'm kind of moving up. And the first point is 0. My last point, at least from the beginning, would be a half of a pi. And I'll write that down for you. It's pi over 2. Okay? And let me 1 second here. So what's the dead center between that? So I'm going to say if I did that, 0 plus pi over 2 is pi over 2. So it'll be pi over 4. I'll neaten this up in a second, by the way. And then I wonder what's the dead center between 0 and pi over 4? We'll add them together. That would be pi over 8. Okay, what I'm starting to realize now is we're counting by pi over 8. I'm going to put that down for you. 0y. I'm sorry. I don't know why I said that. That's xy. 0, pi over 8, 2 pi over 8, 3 pi over 8. It's good if you can count, by the way. 4 pi over 8. Yada, yada, yada. I really mean that. Yada, yada, yada. All right. So I could keep counting 0 pi over 8, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, 9 pi over 8. It gets a little boring pretty quickly. What I want to do is I want to start just writing down the points for you. Erase this table over here. And I want to do, the 0 first. I want to start there. But pretty easy. This also have a pattern to it. It's a counting pattern. So if I did 0, cosine of, 4 times 0 is 0. Cosine of 0 is 1. 3 times 1 is 3. Now if I did pi over 8, 4 times pi over 8 is pi over 2. The cosine of pi over 2 is 0, and 3 times 0 is 0. All right. And again, I'm going through it. Again, you should know these numbers. If I do, 4 times 2 pi over 8, I would just get pi. And the cosine of pi is minus 1, so this would be minus 3. All right. Let's keep going. And my 3 pi over 8 now. If you multiply that by 4, that would be 3 pi over 2. The cosine of 3 pi over 2 is 0, and 3 times 0 is 0. All right, let's go to 4 pi over 8. If I multiply that by 4, right, that would be 16 pi over 8, which would be 2 pi. And the cosine of 2 pi is 1, and 3 times 1 is 3. So I'm kind of ready to put my points down. And what I want to claim to you is that I want to learn by using pictures. And I'm going to put the first point down for you. And someone says, I wonder what that first point is. It's right over here. And where's 0, 3? It's right here. All right, I'll put that down for you. Now, you might be surprised about the next point I'm going to put down is going to be this one. I got some help over here. And I'm going to say I know the y is 0. So I'm going to say that has to be right over here. Now, what's pi over 8? It's approximately 3/8. That's about right. All right, now I'm going to do this one over here. And this is going to be pi over 4. It's about 3/4, by the way. But really, I'm concentrating as a minus 3. It's right over here. All right, let's do this one. Again, I'm concentrating on the 0. That's right over here. All right, let's do the next one. And concentrate on that. And what would that be? That would be 4 pi over 8. All right, I'm going to start writing the other points down now for you. This one. Now, what do I know about this point here? I know the y is 0, right? The question is, what's the x value? Well, I hope you realize it's 5 pi over 8. I'm just moving up. What's this going to be? 6 pi over 8, comma, minus 3. What's this one going to be? 7 pi over 8, comma, 0. What's this one? 8 pi over 8, comma, 3. Hope you realize how easy that is. All right, what's this one over here? Well, it's going to be 9 pi over 8, comma, 0. All right. I'm going to say 2 cycles are done. If you want, you can trace over this curve just for practice. No, you'll never be as good as a machine, at least not for drawing pictures like this. Although I'll be honest with you, some people are pretty creative. All right. What's the other questions they're asking about over here? They're asking for the period. Let me write the period down for you. The period is the length of a cycle, and this cycle starts from 0 to pi over 2, so its period is pi over 2. And what's the amplitude? Well, it's half the distance between the top and the bottom. And if you look at this, oh boy, I forgot to put a parentheses here. It goes up to 3 and down to -3, it's 6 units. So its amplitude is half of 6, which would be 3. Again, I want to encourage you to look at the answer key to make sure you understand that answer is listed for you along with the picture. All right, I'm going to go to the next problem, which is number 2. And that's going to be figure 23. We can go to that. All right, we're going to do this one now. All right, and write down for you. Push this on the side a little bit. And what's that going to be? Y equals. And that's going to be 3 sine pi x minus 2. So begin. That's going to be pi x equals 0. And again, just reviewing what we did in class. Then it's going to be pi x equals 2 pi. So x equals 0, and that's pretty simple. And x would equal 2. So if I put a table down here, I'll put x and y down. It looks pretty simple. I'm going to say 0. Remember, we have 5 positions, by the way. 2. What's the dead center? 1. And that's a half. And this is counting by halves, by the way. 0, 1/2, 1. 1 is 2 halves, and then 3 halves, and then 2. All right, I'm going to put my numbers down now. And I'm going to put the 0 down. A very easy point. And, pi times 0 is 0. Sine of 0 is 0. 3 times 0 is 0. So I get -2. All right. Let me go to the half. And if I did that pi over 2, that sine of pi over 2 is 1. So it's going to be 3 minus 2, which is 1. All right. Now I go to 1. Pi, that would be sine of pi, which is 0. 3 times 0 is 0. So I get -2. Let me go to 3 halves. That's going to be 3 pi over 2. The sine of that's -1. So I get -3 minus 2, which is -5. 2 pi, the sine of 2 pi is 0. 3 times 0 is 0. 0 minus 2 is -2. All right, I'm going to go to my picture, and I'm going to plot it down. And at one point in time, I'm going to do this one first. It's easy. 0 minus 2. Next point is going to be 1/2, 1. Right, I'm seeing this exactly in the picture, by the way. It's right there. All right. Let me push that over a little bit. All right. And let's see, I want to point out I do this point over here. I'm going to do 1 minus 2. Right here, looking at my picture. I'm going to do 3 halves minus 5. 3 halves is 1.5. Minus 5 is right over here. And again, I'm doing these points over here. Very simple. And then 2 minus 2. All right, I want to keep moving. And someone says, how do you keep moving? It's really easy. I'm just simply counting. And I'm counting by halves. So 0, 1/2, 2 halves, 3 halves, 4 halves, 5 halves. I'll write this down for you. Whoops, that's a mistake. Get my eraser. 5 halves, 6 halves. I could do this forever, right? 7 halves, 8 halves, 9 halves, so on and so on. Well, I'm going to do that for you. And I'm looking over here, get my blue pen out. And the next one was 5 halves. What's that's 2.5, right? And what would 2.5 give me? Well, looking at the pattern, I notice it's going to go to 1. I'm just looking at it. I'll point out what I'm looking at. I'm looking at this pattern over here. So let me write that down for you. And what would I say? I would see 1 minus 2 minus 5 minus 2. And it keeps repeating itself. It just keeps going on and on and on. So I'm going to write these points down for you now and make sure I can do that good. All right. So what's this point over here? Well, I said 5 halves, right? Which is 2.5. Comma 1. That was easy. Let me put this point over here. Now what's it going to be? 6 halves, which I know to be 3. Comma minus 2. I'm looking at the table, by the way. What's this point over here? Well, let's see what we did. We did 6/2. This would be 7/2 now, right? And what are we going to get? 7/2 gives you -5. Very simplistic pattern problem. What's this one over here? 8/2, which is 4. And that, of course, if I'm looking at my table, that's -2. All right. You want to trace the curve in. Again, I'm not very good at that. The reason we give you these pictures, we're hoping you learn by using the picture. All right. And that was number 2. This was problem number 2. All right. I guess I didn't write that down. I'll write that down for you. That was problem number 2. I'm going to the next one, which is going to be problem number 3. All right. A little more difficult. Let me get to that. And let me see if I can do that. And problem number 3. Oh, geez, it's right over here. Let me push this over here. Okay. I'll shrink it down a little bit. We'll get to it in a second. All right, a little more difficult. All right, so let's write this down. And I'm looking at it, and this is problem number 3. And what do I see? It's a sine function again. I want to do the begin. And it's going to be pi x minus pi over 2 would be equal to 0. And you would get, let's say, pi x equals pi over 2, or x equals 1/2. Let's do the end. It looks pretty easy. Pi x minus pi over 2. At the end, it's going to be 2 pi, but I'm going to write 2 pi as going to be, let's see, I want to write in terms of halves. So that'll be 4 pi over 2, because that would be 2 pi. This was why'd you do that? To make it easier for me to do the arithmetic. So pi x would equal 5 pi over 2, or x would equal 5/2. And let's look at another easy counting problem for me. And again, I'm going to point out what I mean by that. We're starting at 1/2. And then I'm going to end up at, let's see, 1, 2, 3 at 5/2, right? What's a dead center there? Add them together. That's going to be 6/2 with 3/2, right? This would be 2/2. Very simple arithmetic, by the way, and 4/2. All right, let's plug the numbers in. And so where you're plugging them in, again, I want to emphasize over here into the function. All right, so what would you get? You would get pi over 2 minus pi over 2, which is the sign is 0. The sign is 0 is 0. 2 times 0 is 0, and 0 minus 3, of course, is -3. I'm going to plot that point, by the way, and that's going to be 1/2. I'm kind of looking at that, and the -3 is a little bit easier for me to identify. It's right over here. All right, now I'm clearly seeing that. All right, now 2/2, right? That's 1, right? Well, it's 2/2 of pi minus 1/2 pi, which is pi over 2. The sine of pi over 2 is 1. 2 times 1 is 2, and 2 minus 3 is -1. All right, so let's do that. And again, I'm looking at my picture. Again, you might have a tough time reading scale, but this is this point right over here. All right, the y value is -2, and the x value is 1. Again, they're decimal numbers on the x, so I can certainly read that. All right, let's keep going. I just did this point here. Let's do the next point, which is 3/2. So it's going to be 3/2 pi minus pi over 2. Well, 3/2 minus 1/2 is 2/2, which is pi. What's the sign of pi? That would be 0, right? That's easy. 2 times 0 is 0, so I get -3. Let's plot this point now. 3/2 is 1.5 minus 3. Let's see if I can do that. That's right over here. Okay, let's keep going. And someone says, why do you want to keep going? I want to make sure I understand how to do this. And let's see, 4 pi over 2 minus pi over 2 is 3 pi over 2. That gives me -1 now. And 2 times -1 is -2, and -2 minus 3 is -5. 4 over 2 is 2, and I get -5. Let me put that down for you. Again, the reason we give you pictures, we hope it's easy to count on these pictures. We really do. You're going to learn counting and hopefully some techniques of graphing as well. Let's do 5/2. 5/2 minus 1/2 is 4/2, which is 2. So it's 2 pi. The sum of 2 pi is 0. 2 times 0 is 0, right? And 0 minus 3 is -3. Got this one. That's 2.5. I'm kind of looking at it, and we would get -3. Okay, make sure you can look at the scale and do that. I'm going to trace this in. And that sign, yes, I'm drawing over my own pictures. We'll talk about sage later. All right, I want to put this point down. And so what is that point? Well, do you remember we're counting by halves? So if I'm at 5 halves, the next one will be 6 halves. So that would be the number 3, right? Comma. Well, the pattern's pretty easy. Looking at it, minus 3 goes to minus 1. All right, so looking at the pattern. Let me go backwards. I'm going to do this one over here. Remember, we're counting backwards now. We're at 1/2. Well, if I count back a half, this would be 0. And in the pattern, what would that be? Minus 5. All right. Let me put this one over here. This would be minus 1/2, minus 3. All right, I think I'm done. Right? You can do this forever if you like. I don't recommend it, but you could. So I'm going to write down other things. I'm going to write down, the period. I want to find out what we're doing over here. It's the length between those two. So it's basically a simple subtraction. 5 halves minus 1/2 is 4 halves. So the period is 2. Let's talk about the amplitude. And what's the amplitude over here? Well, it's going back between minus 1 and 5, and the distance between those two numbers is 4. So its amplitude is 2. All right, let's look at the answer key. And what does it say? Yeah, it gives the picture we have. I just stole it from the notes. Okay, I'm going to the next problem, which is number 4. And this is problem number 4. All right, I'll write it down for you. And let me just see if I can maybe, let me see if I get rid of this one here. You know what I'm going to do? I'll just select this thing here. I'll move it away and push this stuff away. Push it all away. Blowing that up over here. Okay, let's write this one down. This is problem number 4 now. And what's number 4? It's the tan of pi x over 5. Well, I'm going to remind you that the beginning of this guy over here is going to be pi x over 5 equals, well, we decided we're going to start the tangent function at minus pi over 2 because it's an asymptote there. And if I were to do that, x would be equal to minus 5 over 2. All right, let's do the end. And it's going to end as asymptote. So pi x over 5, and it's going to end as asymptote, which is pi over 2. Again, this has all been explained during lecture. Hopefully you're paying attention during lecture and you're making sense out of it. So 5 over 2. So what I want to do is I just want to draw in the asymptotes now. All right. And I hope you realize that minus 5 over 2 is minus 2.5. So I'm going to put that in. And I'll write it down for you. That's x equals minus 5 over 2. And what's the other one? 5 over 2. These are things that we've done in lecture. You know what? I know there's a distance between those two, right? So what would the distance be? It would be 10 over 2, which is 5. So I'm going to say its period now is 5 units. By the way, there's no amplitude because these functions, they go on forever. They just keep moving up, right? They keep moving up. All right. I'm going to put my table down. XY, and minus 5 over 2. Still 5 places, by the way. 0 would be the center. And someone says, I wonder what's the dead center between 0 and 5 over 2. That'd be 5 over 4, right? Which is 1 1/4, and minus 5 over 4. Well, these are fairly easy to compute. Just want to go through it quickly with you. At 0, what are you going to get? You're going to get 0. At 5/4, what are you going to get? Just plugging it in, you can get pi over 4. The tangent of that's 1. It should be minus 1. And these are asymptotes. We've already done that. I'm going to plot those points for you. 0, 0. Minus 5/4, right? That's, minus 5/4, minus 1 1/4, minus 1. Well, it's easier for me to identify the minus ones. Let me see. Right over here. All right, other point. let's see, I said what? 1, right? And the y. Draw the picture in. Goes on forever. I'm going to put the other asymptote in for you because I want to draw 2 cycles. Now let's see. If you're at 2.5 and you go up 5 units, you'd be at 7.5, right? Write that down for you. And 7.5 would be, let's see, I'm going up, that'll be 15 halves, right? Well, that looks pretty easy. I guess I could keep moving on that. Maybe put another point down here. Now, I want to point out we're moving up 5 units from the 0. So would this be? This would be 5. And if you look at your graph, it's clearly a 5. Right, these ones over here. I'd like to write them down for you. All right, so maybe it's not terribly important to write them down. You get an idea of the shape of it. All right, we got 2 cycles drawn. Let's look at the answer key, periods 5, and certainly we have the picture there. All right, what's the next one we're going to go to? I think, let me see what I've done so far. Have I done 3? Yes. I've done 4. And now I'm going to go to 5. All right, for a lot of students, 5 is a little bit more difficult. All right, we're not trying to confuse you. We've actually done these in class component aside here. And what we like to do is we like to graph a related curve. I'll write that related curve down in red for you. And then make it in yellow so it doesn't look so obvious. Y equals 2. Well, what's right to the secant would be cosine, right? And that would be 2x plus 3. I'm going to graph this pretty quickly, by the way, because it's easy to graph. At least I think it is. What's the begin? Where 2x equals 0, so x would equal 0. Where does it end? When 2x equals 2 pi or x equals pi. All right. So if I were going the cosine curve in, I'd wonder what it is at 0. It would be 2 plus 3. Put a little table down for you. And again, graphing this yellow curve here. 0. And then we have 3 little thing here, right? And then pi. Oh, yeah, if I put 0, what do you get? Cosine of 0 is 1. That 2 plus 3 is 5, right? If I did pi, it'd be 2 pi, which is cosine of that is 1. It's still 5. All right. What's dead center? Pi over 2. And what would it give me? Cosine of pi. Cosine of pi is minus 1. So 2 times minus 1 is minus 2. And minus 2 plus 3 is going to be 1. This is going to be, let's see, I guess pi over 4, right? I guess I can count, 0, pi over 4, 2 pi over 4, 3 pi over 4. I can plug those numbers in too. And that would give me, let's see, 3. Because pi over 4, plug it in, would give me pi over 2. Cosine of pi over 2 is 0. 2 times 0 is 0. 0 plus 3 is 3. 3 pi over 4, that's still 0. Still get 3. All right, graph that cosine function in. And what does that cosine function look like? 0, 5. Let's see, pi over 4. I'm going to do pi 5 then. And where's pi? Pi 5's over here, right? That's amazing. Look at that. All right, then let's do pi over 2, 1. Pi over 2 is like 1.5 or so. There. You get the idea? All right, I'll got that one down. And the next one is going to be, let's see, that pi over 4. And pi over 4 is like roughly 3/4. It's tough. But you know what? I think we've done this in lecture, right? I'm going to write these down for you. All right, I'll put the yellow down later for you. This is going to be x equals pi over 4. And this can be x equals 3 pi over 4. All right, put the points down for you. Put that in for you. Now, we didn't want to graph that. We wanted to graph out this guy. So why put the asymptote in? Division by 0 there. All right. What's this guy going to look like? Basically, the reciprocal. Put this over here. I'm going to put in more cycles, don't worry. Put down another asymptote here. Let's see, I might as well do this one over here too. Let's write them down. Looks pretty easy. X equals minus pi over 4. And what's this one going to be? X equals minus 3 pi over 4. All right. I'm going to put some points in for you. I'm going to put a point right here for you and a point here. I think I know those points, by the way. It's 0, 5. Again, we're doing this graph here. And this point over here is going to be what? And I got to look at that myself. Make sure I'm not doing any big mistakes over here. Pi over 2, 1. All right. And let me see what else I have to do. I guess I do one more cycle, right? Maybe 2 more cycles. I don't have to do too many. I'll do this one over here. Wow, I wonder what that point is. Well, I do know the y-coordinate's 1, right? All right, let's take a look at it. Oh, there's so much symmetry. It's ridiculous, isn't it? It's minus pi over 2. Okay, so that graph is done. And I'm going to go to the next graph. Is there any other questions on that one? No, let's take a, oh, period. I didn't write that down, period. What's the period? It's the distance between the beginning and end of it. And what's that going to be? Pi. It takes pi units long to get there. In other words, the distance between those two is pi. All right, the distance between those two is pi. All right, let me see, 3 pi over 4 minus pi over 4 is 4 pi over 4. Yeah, it's pi. All right, let's go to the next graph. That was question number 5. And make sure I'm saying that correct. Yep, this was number 5. And now we're doing number 6. Let's take a look at it. And let me see if number 6 is up here. Okay, yeah, I think that's it. Let's see if we can do this. Shrink it down a little bit. And what am I going to graph? I'm going to graph a related function, y equals sine of 4x. Should go quick, by the way. The beginning, when 4x equals 0, x equals 0. The ending, just to begin, the ending would occur when 4x equals 2 pi or x over 2. All right? So certainly if I was just going to graph that, just do it on a side over here, this would look sort of like this over here, right? With the beginning being 0 and the end being pi over 2. And we get asymptotes here, here, and there. Let's write that down, and I'll put it in red. So we can get an asymptote at 0. I'll write that down for you. We're going to get an asymptote at, let's see, the distance between 0 and pi over 2. I'm sorry, yeah, pi over 2 with pi over 4. Yeah, I'll put the next one down too, right? These are going to be really easy to put down if I know how to count. And that's going to be at pi over 2. Now, pi over 2 is about 1.5. You know, I'm just rounding pi to be about 3. And that seems relatively simple. And these points over here also going to be relatively simple. And what's it going to be? Well, the sine function there, what's it going to be? Let's take a look at what value here. And again, I want to point this out to you. This is pi over 4. This point over here would be pi over 8. And this would be 3 pi over 8. right, let's write that down. So pi over 8, comma, 1. And this would be, let's see, I'm just counting 0, pi over 8, 2 pi over 8, 3 pi over 8. I'm just counting. Comma, minus 1. Just draw it in. Draw it in. I think you're getting an idea. I want to point out when you're doing web assign, you have to identify this by looking at the graphs. I want to point out, do the groundwork first. Just don't do a hunt and peck. Try to see if you can do it. All right. So I guess for the most part, we're kind of done with those picture things, at least, and maybe not. Let me do number 7. I'm going to push this up. I'm going to read 7 to you. And it says, in a certain region of Australia, the population of a picked up a kangaroo is modeled by a function. I'll write the function down. Population is a function of time. By the way, it's saying it's a cyclic population. So I'm going to put 1,300 minus, it says 140, sine of 2t. All right. I bet this has something to do with graphing, by the way. It says, according to the model, what is the maximum kangaroo population? So I'm going to just, kind of graph it out. I think the graph should be pretty easy. I'm going to put down 2t is 0. This would be the begin for me. And the end is when 2t equals 2 pi. So t is 0. T would be pi. All right. That looked pretty simple. I'm going to put my table down. My table is going to be t and population. It starts at 0. At least that's what I'm going to start to measure. And this is a cyclic population. It goes up and down, up and down. It's kind of typical with some populations, not all. So let's take a look. And I'm going to stop at pi, right? What's dead center? Pi over 2. Pi over 4. Not so bad. Let's see. 1 pi over 4, 2 pi over 4, 3 pi over 4. Should be easy to plug these numbers in. The sign is 0, 0. So this is 1,300. That was easy. Pi over 2 is 1. So it's 1,300 minus 140. Right? 1,300 minus 140, which is going to be, let's see, 1,300 minus 140 is going to be 1,160, right? Maybe these numbers are not really that important to you. 1,300. And then 3 pi over 4 would give me minus 1. So it would be 1,300 plus 140, which is 1,440. And then I get to that, the 2 pi thing. It's not 2 pi 0, so 1,300. Again, it's cyclic. I want to point out what I mean by this. We get a curve that looks like this here. I'm going to put the points down for you. So the first point 0 is 1,300. Circle that for you. Then at pi over 4, this point here, the population goes down. Then it goes back to the 1,300. And then at 3 pi over 4, it goes to 1,440. Of course, what's the question? What's the maximum population? Well, look at it. It's 1,440. It's right over here. Let's look at the key, see if you got it right. Yeah, we got it right. All right, let's take a look at the next one. I know these things are difficult. We want to encourage you to think about what you're being asked to do. And I'm going to go to problem number, I guess this is problem number, and I'll make sure you understand what this means. Problem number 8. And it's the cotangent of x equals the root of 3. Now let me read it to you. It says, use a graph to approximate to 4 decimal places. I'm actually going to, try to show you what I mean by that when we're doing software, but I'm going to look at the picture. So if you're going to use a graph and you're going to approximate to 4 decimal places, I would recommend you use a computer to do that. Now someone says, did you use a computer to draw that picture? I did. All right. I want to tell you what I drew a picture of. I drew the picture of the cotangent. I drew it. Now I want to point out what I mean. I drew y equals the cotangent of x, and that's the first curve I graphed. The second curve I graphed was y equals root of 3. So I'm going to put this down for you, and this is y equals root 3. Write this over here. And these things over here are the cotangent functions. Again, if I was doing this by hand, I think I'd get, a ballpark figure, but I'm not going to get those values. Now, what they said is, can you come up with an approximate answer where these things are intersecting? I know it's tough, right? I'm kind of looking at it. And so when you're looking at something, can you determine what the values are by looking at it? And I'll be honest with you, sometimes I can't because the scale is so hard to read, you don't know what the numbers are. But I'm going to look at this thing, and I'm looking at this. I'm looking at the curve over here, and I hope you realize it's minus 5 point something. All right, I hope you realize that. Look at the picture. And looking at this one over here, I hope you can realize it's minus, let's take a look at that. I'm going to say about minus 2 point something. Now, by the way, I'm looking at it, and I'm going to say, maybe it's a little bit below the minus 2.5. So I'm going to say minus 2.6. Let me see if I can do the thing below the minus 0.5, by the way. I'm going to say it looks, I'm going to say minus 5.8. I'm ballparking it. All right. Let me look at this one over here. And these are the x values, by the way. And the x value over here. Let's take a look at that. And again, it's something hard to read the scale. There's no doubt about it. I'm going to say, roughly speaking, about 0.5. Let's look at this one over here. Again, I'm looking at the scale. And I'm looking at it. It's certainly between 2.5 and 5. And I'm going to say roughly around, it looks like it's close to 4, but above 3, close to 4. I don't know, maybe 3.7. I want to point out they are equally spaced. All right, I'm definitely seeing that. So I'm going to say that's rough. That's an approximation looking at the picture. I want to get to the answers, though. All right, I really want to get to the answers. So someone says, how would you do that? And what I'm going to do is I'm just going to go through it with you. This is something new to you, but I want to get to the answers. I actually want to get to the exact answers. So let's write this down. And they said cotangent of x equals root of 3, right? That's not so bad. But like I mentioned, I don't like cotangent. And someone says, why don't you like cotangent? I'm not that familiar with it. So what I want to do is I want to just simply talk about tangent. And 1 over root 3. Now I want to go back to that, the wheels in the bus go round and around, so to speak. And I wonder, where does the tangent, what value of x would make the tangent equal to 1 over root 3? And I think I got an idea about that. Now, what I mean by that, there's something to do with a reference triangle. That would be 1, root 3. And I think I know that one. That's a 30-degree reference. All right. And the question becomes is, I kind of got the idea. Now, in the first quadrant, 30 degrees is 30 degrees. That's its reference. So I can say 1 occurs here when x equals 30 degrees. Now, where else would the tangent be 1 over root 3? All right. I don't know. And you have to start thinking, right? And I'm going to say, like in this quadrant over here, what would that be? If I did that, and take a look at that, right? So the reference is still 30. So I'm going to say it would be what? Well, it would be 180 plus 30, which is 210 degrees, right? Hope I didn't go too fast with that. Now we don't like using degrees, so I'm going to write this in radian measure. And so 180 over pi. I'm sorry, I'm daydreaming here. Pi over 180 degrees, right? That's going to be pi over 6. And this one over here, well, that's 7 pi over 6, right? That's 7 times 30. So I got 2 of them. However, there's an infinite more to come up with. Here's the deal, though. You got to stick between. Let me go back to my notes to make sure I'm saying this, what they said they want to stick between. I got to be careful here. Oh, minus 2 pi and 2 pi. I'm going to write this in terms of 6. So minus 12 pi over 6 and 12 pi over 6. Clearly, pi over 6 and 7 pi over 6 is there. And I'm going to, I don't want to go further. I want to go backwards. And how do I do that? Subtract away 2 pi. So let me put that down for you. Pi over 6 minus 2 pi. That would be pi over 6 minus, well, let's see, that would be 12 pi over 6, right? Which would be minus 11 pi over 6. You may wonder what I'm doing. I'm going backwards into the negative region. And I want to take this one, the 7 pi over 6, and also go backwards. I'll put that down for you. Subtract away 12 pi over 6. What would that give you? Let's see, 3 minus 5 pi over 6, right? Okay. I do recommend you use a calculator. And on the calculator, I want to point out, I want to put these numbers down in order for you. All right, starting with the smallest number there. So I'm going to say x equals minus 11 pi over 6. If you use your calculator, this number here would be minus 5.7596. X equals, the next number in order is minus 5 pi over 6. If you use your calculator, that number returns to be minus 180. The next number in order would be pi over 6. This would be equal to about 0.5236. And the next number, x equals 7 pi over 6. And this is approximately equal to 3.6652 on a calculator. Again, I want to point out, we looked at the picture. I'm going to go over that with you again. And I want to point out these numbers that we saw in the picture are right up over there. Minus 5.8 approximately, picture, minus 2.6 picture, 0.5 picture, and 0.37 in the picture. Things work out nicely. They really do. All right, next thing up, I have to go to a computer and go back to my computer. And I want to just briefly go through that with you. And I'm going to switch screens again. Just give me 1 second. And all right, so I'm going to go Grapher. Let me make sure I got the screen going right. I'm going to go to the Grapher application. Just give me a second to get there. I like Grapher. And the reason I like Grapher, it's easier for me to use it. All right. I'm also going to talk about Sage, but this is going to be graphing the absolute value. No, it's going to be tough to do that by hand. I guess you could, though. X times the cosine of X. All right. So I did this over here, and I'm going to zoom out. And they can see what I'm doing over here. I'm going to grab it, pull it around. I'm going to zoom into a region of it. And I'm going to zoom into a region that looks sort of like this over here. All right, and then what I'm going to do is I'm going to look at this, which I just graphed. It's really remarkable how quick I did it. It would take me some time to do that. And look at the graph that's being provided, relatively the same graph. All right, let's go to the next one. Again, these would be tough to do by hand. I want to point out, if you're using software, you're free to use any software you like. So I'm going to say absolute value of X, and then plus the absolute value of cosine of X. Put that down. I'm seeing the picture. I want to look here, and I want to point out I'm seeing the picture that I just graphed, and I'm seeing the picture they provided to me. All right, pretty simple. All right, let's go to the next one. Whoops, sorry about that. This is the next one over here, and that's e to the minus x squared. Again, I'm using software for a reason. These are too difficult for me to do by hand. E to the power minus x squared times the sine of X. All right. Oh, I don't see it. Do you? Oh, yeah, it's right there. Look at that. All right, pull it up. There's a problem with them students. They don't see things because they're not looking. Kind of hard to cure that kind of blindness, by the way. All right, so let me zoom out a little bit. You get the idea. I can do a lot of different things over here. I can maybe just do a little bit better over here. Whoops, I didn't mean to do that. Let me go undo it. Undo it. And let me just do this over here. All right, let me look at the graph they provided to me. I'm seeing the graph. It's really easy to type that in. And this graph over here. All right, let me just talk about Sage a little bit. I know sometimes I do the co-calc, sometimes I do the terminal. Let me just quit out of here. I don't want to save that. Don't save. You should learn how to use technology. And give me 1 second here. And I'm going to do Sage from a terminal. I think last time I showed you Sage, I was doing it from co-calc. That's the online version. What's the advantage of doing it on my machine? The big advantage is that my machine is the one doing the processing. Now, granted, it does, sort of like Lance's server for me. I'm running 9.1 of Sage. You can see that clearly on my screen, and it's using Python 2.7.15. Let me point out, you can also do this going to CoCalc. Let me remind you about that. That's Sage, math.org. You might have to create an account, but CoCalc is free online. Launching it. Just give it a second to launch. And remember, new worksheet. It's a Sage worksheet. And remember, if you type in a command like 1 + 1 and hit the return button, nothing's going to happen. You have to hit Shift, Enter for it to compute. You have to do that. If you don't do that, it's not going to compute it. All right, and there's advantage to that. You know what I'm doing over here? What I did was I did 2 commands at once because I hit the Shift, Enter, and it did both computations simultaneously. All right, let me go back, and I want to just see if we can do that. And I want to go back to the Sage. I'm going to close out another window. I'm going to type in reset. Again, you're more than welcome to do that on the CoCalc website. X equals var. We've done this before. And it's kind of redundant. You don't need to do that in Sage because X is considered a reserved variable. F of X. You know what? I'm getting kind of tired of typing. That's what's nice about code. I can copy paste. I still understand what I'm doing though. What does it say? F of X is a function minus 3 times cosine pi minus 2x plus 2. What's this one over here? I don't know. Let's copy paste, right? And I'll put this one over here. And it says plot. It says plot the function where x minimum is -1, x maximum is 7, y minimum is -1.5, and y maximum is 5.5. What it's doing now is it's actually going to create a graphic primitive, but it has to open up another application to display that. And the application that's opening up is an application on my computer called Preview. It actually just graphed it out. All right, let's do this one over here. It should be somewhat familiar to you. And that's g of x. G of x is the absolute value of x times cosine x. We just did this a little prior. I'm going to copy paste. And what it's going to do is going to launch that application Preview and display that computations output. All right, that's about it. Hopefully this was helpful. Again, if you need additional help, come by during office hours. I want to point out though, it's incumbent upon you to pay attention during the lectures, to reinforce and study those lectures, and then to do the homework on your own. If for whatever reason you're spending a lot of time, you're not getting something, come by and get the help, and we'll try to help you out, okay? All right.